hope you all are doing well. I welcome you all to Tech Saturday webinar with TimesPro. Today we have a session on much awaited topic, right, which is from beginner to expert, a step-by-step guide to launching your EV career. As the world moves towards sustainability, the electric vehicle industry is leading the charge. And with a focus on reducing the carbon emissions and combating the climate changes, EV offers a promising solution to traditional transportation challenges. So, today we will be diving into this dynamic industry to uncover the secrets to a successful career path within it. Now, allow me to introduce our distinguished speaker for today's webinar, Dr. Shantanu Mishra, with a remarkable journey spanning across both academia and industry. Dr. Mishra brings a wealth of expertise and insights to the table. So, let's take a closer look at Dr. Mishra's impressive background. Talking about his educational background, he earned his BTech degree in electrical engineering from the College of Engineering and Technology, Bhubaneswar in 1998. Continuing his academic journey, Dr. Mishra pursued MTech degree in Energy System Engineering from Indian Institute of Technology, Chennai in 2000. Further, Dr. Mishra, in his education, he obtained a PhD degree from the Department of Electrical and Computer Engineering from the University of Florida, USA, in 2006. Talking about his professional journey, he honed his skills as a staff application engineer with the International Rectifier Corporation, now known as Infineon Technology, in Rhode Island, USA, from 2004 to 2008. After that, he transitioned into academia. Dr. Mishra served as a professor with the Department of Electrical Engineering at Indian Institute of Technology, Kanpur from 2008 to 2023. In 2017, he expanded his horizon as a visiting professor at the Center for Power Electronic Systems at Virginia Tech, USA. Currently, Dr. Mishra holds the prestigious position of professor with the Center for Automotive Research and Tribology at the Indian Institute of Delhi. Dr. Mishra's research interests are diverse, including power converter design, implementation, control, and application. He is widely acclaimed for his contribution to the field and served as an associate editor of several esteemed journals, including IEEE Transactions on Industry Application and IEEE Transactions on Power Electronics. So today, Dr. Mishra will guide us through the intricacies of launching a career in electric vehicle industry. And here is a glimpse of what all we will be covering. He will cover the importance of EV charging infrastructure, building blocks of charging infrastructure, and engineering concepts for EVs. So let's give a warm welcome to Dr. Shantanu Mishra as we embark on this enlightening webinar journey together. Welcome, Dr. Mishra.
Wow. I didn't know that I had such distinction. Anyway, that's absolutely, yeah. You have a way with words. I can
Thanks.
see that. So, what I will do is we will go through this uh, interesting uh, presentation. Okay, and after that, I will request you all to ask me questions. See, you ask questions. We are in this business of talking, right? So, if you allow me to talk, I will talk for hours. That doesn't mean anything actually. So let's get something out of it, and let's see how that will help us. The primary intention here will be hopefully I'm audible. Okay, so that is my, it's okay, right?
Yes.
Okay. All right. So see, the primary intention here is that like while doing this EV or while doing anything in life, we have to have trust in ourselves. Okay, which is something that is missing nowadays. Like people are afraid of doing mistakes. Okay, which is not true. When I was young, actually, we did hundreds of mistakes, and we were spanked all around, and that was in fact the fun of life, right? So that has somehow changed, and like if we want this EV to to come to us and improve our lifestyle and improve our economic status, then we should not be worried about doing mistakes. Okay, so we will be doing mistakes, and that is how we will learn, and that is how we will improve ourselves, rather than West telling us what we should or should not do. So one of the things that I will always tell in a class is, when your house is on fire, you don't retry triple E papers, right? So that is something that is very relevant, and we have to have our own thought and own feeling. So this will be kind of reflected in what I will be going through today, and based on that, you ask me questions, and you see how this course may or may not help you in your career building. Can't talk in Hindi. See, I don't know whether there are Kapil. I don't know whether there are South people here. Normally, we will talk in English. I am not sure. I have to ask. I mean, should I talk in Hindi or English? Ma'am, should I talk in Hindi or English? I actually don't know what to do. Okay,
Yeah,
because
we usually conduct our webinars in English, but I think if you are comfortable, we can do a mix of both as well.
Okay,
But
so
mostly
Kapil,
the
you can ask
languages.
me question. Yeah, you can
Yeah.
ask me questions, because the mode of education, mode of this particular course will be in English actually, but that doesn't mean that we cannot. हम आपको समझा नहीं सकते हैं. I mean, wherever you find that we can be of you are having problem, then just let me know. Huh? So let's go forward. See, there is a there is something that you are looking from this course. Okay, mostly when I was a professional, I will always take a course not to learn. Actually, I just wanted a break from what I was doing. Okay, I was never interested in learning. Most of the time, I mean, not all the time, but most of the time. Okay, so there are people from South India, so they will. Uh, Okay, so Kapil, आप मुझे पूछ लीजिए. Whenever you have a question, just let me know. So that will be, I think, true for many of us. Like having a fresh look at our career is what we are looking for. And as EV is a buzzword, let's see whether that buzzword really lives up to it or not. Okay. And whenever you are learning about EV, don't mistake me. Okay. So like think about it. Just sit down and think that if I give you 30 lakh rupees and ask you to buy a car, will you buy a EV or not? Okay, that is a question. If you can answer, then you are answering your own doubt whether EV will come or not, right? So, because like you, everyone will be thinking. And I will tell for myself, if you give me 30 lakh rupees and ask me to buy a car, I will not buy a EV. Okay. Why I will not buy EV? The reason I will not buy a EV is not because EV is bad. EV is actually very good, because technology will be there. Mahindra, Tata's, they have developed good technology, and like Hyundai, they have all developed good technology, and those cars are actually pretty good. But the problem that I face when I have a car is whether, if my car discharges, then whether I can reliably find a place to charge my car or not. Like something like petrol, which is happening very easily. Like if I run out of petrol, I know that there are petrol pumps around me. So for EVs, like for EVs, that is something that has to be established by the system in order to give confidence to people that EV will come. So therefore, EV charging infrastructure is one of the primary, in fact, one of the major reason why EV may or may not fail. So that is in fact why we have been asked by the government to offer courses on EV charging infrastructure. So the aim that our like institution is trying to achieve through this is to bring awareness that EV charging infrastructure is a necessity, and whether whatever we are doing with EV charging infrastructure is by our own, or we are buying out the technology from outside. Because if you are buying out the technology from outside, you don't know what to do with it, right? You can put the charger today, but tomorrow when it goes bad, you don't know what to do with it. And we are not talking about place like Delhi. We are talking about Rudraprayag, let's say, which is like, even though it is 300 kilometers from Rishikesh, it will take about 13 hours to go there, right? So we have to have expertise there to rectify those chargers and charging infrastructures if the need arises, and that can only happen when there is an organic development in developing this EV charging infrastructure, right? So this is precisely what that we will be kind of discussing. So I'll go to the next slide. Like, is EV new? No, EV is not new. EV has been there for a long time. Okay, so like I'm giving you examples here where 1966 General Motors have had electric cars. Enfield had electric cars. So this has been there. It's not like something new. But what has changed is certain technology has changed, which has made EV more viable in today's day and age. Okay, so previously whatever EV was there were not able to go a longer distance because certain technology were not mature enough to support that activity. But that maturity has come now. Okay, so that is why there is a interest in EV. Okay, environment is an interest, but environment is more a narrative rather than an interest. So वो narrative बनाया जाता है क्योंकि वो environment is something people will understand. Okay, but unless the technology is there to support that activity, it will not come through. So that you can clearly see that even though 1966 it was there, it was not that common. I mean, we don't see in electric vehicles of that era, right? But currently we can see electric vehicles. We have blue cars and things like that, which we see. We have scooters, electric scooters, etc. So it is more prominent. The reason is that certain technologies have changed. We will see what technology have changed, which has made EV more viable in today's day and age. All right. So if you look at EV, there are many types of EVs. So battery EV is one type where there's no petrol there, so there's no gasoline there. So with the battery itself, you are basically running the car. But there are other types of EVs where both gasoline as well as energy regeneration from the braking, etc., are helping the EV. So we will mostly be talking about battery EV here. We will not be talking about hybrid or PHEV, right? So this battery EV is what we are kind of talking about in today's lecture. So now, like, what is this EV? Is it different from any other car? Actually, if you have been into an EV, it is actually not that different. The reason it is not different is EV has two parts. One is the part that looks exactly similar to a normal car. The second part is its propulsion. So in the normal car, the propulsion is through a IC engine, right? So through a internal combustion engine, we'll put petrol into it, and then the vehicle moves. But in EV, there's a battery. You charge the battery, then you move around, then the battery discharges, you charge it back again. Okay, so that is the whole idea. So that means when we are talking about EV, there are two layers of things that we are talking about. One is when you enter into a EV, what you see, and second one, when you enter into a EV, what you do not see. So what you do not see is how the propulsion is happening. That means the propulsion is happening because of the energy stored in the battery. Okay, but in IC engine, the propulsion is happening because of the petrol that you put, and the IC engine basically works. But other than that, how the EV looks like, all the entertainment system, the power window, power door, all these things will be exactly the same. The reason these things are made exactly the same is because when you enter into a car, you should not feel very different from what is happening, right? So that is why it is intentionally made exactly the same, right? So that is the whole idea of it. Now, like, if you look at a EV, like in the course, we will be mostly talking about the electrical aspect of EV. All right. So what is electrical aspect? So there is a battery there. Okay, so now this battery takes energy and drives a motor. So this motor is actually connected to the wheel. But when you are driving a motor, then you need control over the motor. So that is happening through a thing called drive. So that is a there is an electronic circuit that is actually the brain of the motor. It's like there is a motor which is the muscle, and then there is a brain. It is like similar to your house, right? Your father will be the energy, and then the mom is the brain, right? So whatever mom says will happen. So this drive is similar to that. It is telling the motor what to do and what not to do. And then if you go, so this is precisely what it is. This is called drivetrain. So there is a battery, you have energy, and then you basically drive the motor, and the motor is connected to the wheel. Now wheel, this motor is basically having a like a muscle, like motor is the muscle, and then there is a brain that is basically controlling whether I should go fast, go slow, when to brake. All these things are decided by this drive circuit. All right. So now, in order to once you move around, then what will happen is that the battery will discharge. So when the battery discharges, what will happen is that you will actually charge the vehicle. So how do you charge the vehicle? All the energy has to come from the grid now. So because I mean, either it has to come from somewhere outside. Normally the grid is the one that is in megawatt and gigawatt level. So that is where from the energy comes. So you basically take the energy from the grid and convert it into a format that the battery can accept, and then charge it. Okay, so the energy is actually coming from the grid, and through the charger we are basically charging the grid. So basically, if you look at this scenario, like if I go back and look at this scenario, so just think about it for a while. Huh? Just think about it in a plain thought. Think about it. Whatever on the top I am showing is inside the car. Okay, and this charger and the grid are outside the car. So that means there are two levels of electrical circuits that you see. One circuit is inside the car, which consists of a battery is cooling, what electronic circuit should be there, then a motor, then the motor is connected to the transmission, then the motor is being controlled through a drive, and this complete circuit will be called a drivetrain. So everything that you see on the top is the responsibility of the car manufacturer. Okay, and car manufacturer doesn't want you to touch whatever is inside it. The reason is that if anything goes wrong, no one will say that A or B has done it wrong. People will straight away say that Hyundai car is bad, or Tata car is bad, or Mahindra. So the onus of what is happening inside the car is actually with the car manufacturer. Okay, so that's why no one wants you to touch whatever is inside it. So the only way you can influence what is inside the car is when you work for that company, either as a consultant or as an engineer there. Outside person like me, if I say that Mahindra, why don't you? I have a very good onboard charger. Why don't you take it? They will say that, oh, thank you very much. They will not care about it. The reason is that, I mean, it is not proven. I have not proven myself to Mahindra. And whenever anything is put inside a car, it goes through hours and hours of testing, because the reason is that the testing has to be such that it has to be absolutely picture perfect, because people will take cars hundreds of miles into the wild and come back, and we want absolute reliability with whatever is happening inside, right? So therefore there is something inside the car, and then let's talk about what is outside the car. What is outside the car is the grid is there, the charger is there. So only thing the charging company is saying is that, okay, if the car requires this kind of charging, this kind of energy, I will provide you this kind of energy. I'll come to that. How is that decided, right? So this charging is something that actually we can influence from outside. The reason is that this is something that we can build. Okay, and as long as we are following certain protocols that the car manufacturer is telling us, that means car manufacturer is telling us that there is a certain way I will do a handshake. So if you can do this handshake, I will take energy from you. So this charging thing we can influence. Okay, people can influence, and there are many companies which can pop up because of this charging infrastructure, because that is something that gives that is something that can be outside, that external investment will be okay there, right? So this is what the charging infrastructure means. So we are actually worried about what is happening here, and what is happening here, and how it is happening with the grid. And it is not an easy thing. The reason is that when you are charging, there are many things that will come into picture. Charging energy will come into picture. How much energy you are taking is coming into picture. How do you pay is coming into picture. That means your credit card information is going there. Whenever your credit card information is going on the web, then you have to have cyber security, that has to be taken care. So on top of that, there are a lot of standards that have to be made, and on top of that, there are like n number of things have to be taken care in the background, so that the charging infrastructure works in a picture perfect manner. There cannot be any cyber attack. The charging infrastructure cannot, I mean, all of a sudden hundreds and hundreds of vehicles will charge and put the grid down. That is also not allowed. So all the things on the background has to be taken care in order for the charging infrastructure to work in a certain way which is reliable, right? So that is what the overall system is, right? So now when you think about EVs, there are many different things that are where research is being done, and I will tell you where we will be focusing in this particular course. So you can think about battery cooling. So battery technology, what kind of a battery technology will be used, what kind of a cooling will be used. So that is another. The aerodynamics of the car, these are all mechanical stuff. So that is also a research topic. How should be the aerodynamics so that with minimum energy you can drive. Then you have health monitoring. That means anytime there is something going wrong inside the car, we should have a prior warning. So that is called health monitoring. So we are always monitoring the health of the system inside the car. Then what are the efficient material that can be used. So these are all the things that I am talking here are all mechanical stuffs, okay, mechanical, chemical engineering stuffs, and they're absolutely essential. The reason is that without that the system will not even work, right? But this is not something we will focus in the particular course. In this particular course we will be talking about a little bit about the battery. Yes, we'll be talking a little bit about the battery, but mostly the electrical part will be covered. We will be talking about what kind of a battery is used, why this kind of a battery is used, what is BMS, what are the type of protection that will be there. Then motors, what type of motors are used, why this kind of motors are used, those things we will cover. Part of motor drive will cover. We will not be concentrating on motor drive a lot. We will concentrate on what are the fundamentals of the motor drive. But most of the time we will be concentrating on the charger. In fact, 70% of the time of this particular course, the first part also we did the same thing, and we will be concentrating on the charger design and what are the things that are inside the charger. And you don't have to build the whole charger to be a millionaire. No, charger has hundreds of things. You build one of them, then you will be a millionaire. Because like you can think of it like you don't have to sell all kinds of fruits to become a millionaire. You can sell only one fruit and be the expert in that fruit. Okay, you just have your supply chain, and so whenever you see a charger in one of the misconception that people have is that if you don't have the full charger, you cannot sell anything. That is not true. If so, in the course, we will divide the charger into many different parts, and we'll talk about what are the different parts and how they work. And maybe you can take it up. Just making the wire will also make you a millionaire, because if you are having thousands and thousands of chargers, people will require thousands and thousands of kilometer of wire there, right? So there is a special type of wire used in this kind of system. This is called leads wire. So if you have a manufacturing company that only deals with leads wire, okay, so then also you are okay. You can only make the magnetics, you can only make the thermal design, and you can also combine them together and make the charger. You can only make the plug, that is also fine. right? So these things kind of will kind of cover in the coursework, that what are the exact things that are there, and where where we need our expertise, so that we can take care of the whole charger. So the overall idea is to have a organic development of the charger design, so that we can contribute to the confidence of our people, that if they buy a EV, they will be saved. I mean, they will be okay. All right. So similarly, we'll like Professor Panigrahi, who is a coordinator of the course, normally talks about grid interaction of the charger. So, like, what are the things that you should know in when you are connecting? Where the power will ultimately come from the grid. So, what are the protection standards? What are the communication? What are the power quality standards that you have to take care? So those things will cover. And then thermal design. Of course, I will talk about the thermal design of the charger, like when you have MOSFETs. And inductors and capacitors, how do you cool them? Okay, so power electronic engineers are trained in many different things, like a person like me. So we'll be trained in magnetics, we'll be trained in control systems, we'll be trained in thermal design, we'll be trained in power converter circuit design, PCB design, everything we will know. The reason is that unless we know this, we will never be able to make the charger ourselves. And we do that all the time with many sponsored research, like we work with many companies and do that, right? So vehicle aerodynamics, again, these are all mechanical stuff. We will not cover in this course. Material, EV material, we will not cover in this course. Health monitoring also we will not cover in this course, but we will cover the charger design and its interaction with the grid. All right. So let's lightly discuss what this is. Like, we have petrol pump, we fill our vehicle, and the IC engine runs. Similarly, we have chargers. We charge the vehicle, we run out, the battery discharges, then we charge it again. All right. So now the question, one thing that comes into picture is that the timing taken in charging. So why people, why let's say a person like me who is very confident of a IC engine, not with a charger. The reason is that the charger takes a longer time to charge a battery compared to a petrol pump, where you go there and spend 3 minutes of your time, fill up your tank and go. Right. The same thing is not true for a charger. Okay, why it is not true? So this next picture will give you the answer. See, you can think about a human being. Like, think about like my daughter, or I mean any of the kids that you know. So in 13 years they come to this height. Why? Because it is a chemical process. So they eat, they slowly grow up, and then they become a teenager, right? So it takes about 13 years. So in order to make them from 5 centimeter to 1.5 meter, it takes about 13 years. But think about a building. Like, in 2 months you can build a building. The reason is that a lot of chemical energy that people have acquired, they go there and then dump it on building the building, right? So the same thing is happening there. The left hand side is something that is happening with a petrol, with a IC engine. The right hand side is happening with a electric vehicle. So like when you are actually using petrol, you are actually, like, millions of years has taken to make that petrol. You are just dumping it into your car and driving it. But think about a battery. Battery charging is a chemical process. So the chemical process normally takes time, because it has its own way of doing things. So you can speed up that chemical process, but at many risks. Okay. So it is something like having steroid to have muscles, right? Yes, you can do that, but then there are other demerits with it, right? So the same thing will be true for the battery. Yes, you can charge a battery in 5 minutes. Yes, to sell your EV, people will say that, okay, I can charge your vehicle in 5 minutes. But another problem, what is the cost of it? So obviously you cannot do that all the time. You can only do that at only few times. Right. So because this is a chemical process, it takes its own time, and so this is one of the biggest challenge that we will face as a like, if we want to popularize EV. So there are many many alternate things that are being done in order to take care of it. Something like battery swapping, something like we will have like flash chargers, right? Flash chargers for our phone. So similarly, we are thinking of flash chargers for the electric vehicle. So there are many alternate things that have been done in order to take care of it, so that people will not be stuck on the road. Okay, but that is something that is a part of research, and that is something that is where we have to put our energy, what is good and what is bad for our country. We cannot be thinking of what the Americans or the Westerners will give us. We have to be thinking like this, like the, if we want things to succeed, it has to be under our control. That is the whole idea. Okay, so this is something that I already told you. Petrol is a chemical process, and then that, but battery charging is the charging takes a longer time because it's a kind of a chemical process. So now I was talking to you about, there are technologies that have changed. That is why EV has become popular. Like why 66 it was not popular, and why people are talking about it now. And the narrative that is told to us is that it saves the environment. Yes, it saves the environment, but environment was bad before also. When I was younger, people were talking about there is a hole in the ozone layer. Environment was always bad, right? So, but why are people talking about it now? The reason they are talking about is that because the technology is now there for engineers to support their willingness to help the environment. So the technology was not there before. So there are two technologies that have changed. One is battery technology and another is power electronic technology. So these are the primary technology because of which EV has become viable. Battery technology, like I will tell you in the next slide, that like now we have lithium ion battery compared to lead acid battery. So in India, people are trying to use alternate to lithium ion because we don't want to import lithium ion. So government of India is putting a lot of effort on what kind of a battery that we should use so that it is under our control. Like, can we use magnesium as a thing? So there are many alternate. I will not know much about it, but I hear my friends talk about it, that there are a lot of alternate technologies people talk about. Even though they are 70% efficient, that's fine, because if it is under our control, it doesn't matter what others say. Like we it is under our control, we can make it anytime. Even though it is 70% efficient, that's fine. Right. So that is, there are alternate technologies they're talking about, but lithium ion battery like has really been the game changer. So lithium ion battery has very good energy density. In smaller area you can have a lot of energy, and that actually makes the distance that you go with a car higher. Then the depth of discharge is actually very good. And one of the primary thing that goes well with lithium ion battery is that it can be charged at a very high rate. That means without any heating problem, you can actually charge your vehicle in certain minutes, right? So but even though like I just told you that it cannot happen all the time, but at least it has the capacity to charge in 2C or 3C. That means at a higher rate, so that in half an hour or 15 minutes you can actually dump a lot of energy into the lithium ion battery. So this technology has actually helped us in making EV a little bit more popular. The second technology that has happened is, like, if you have been an electrical engineer and you have taken courses, you remember we were taught thyristors and things like that, right? So thyristors were there in 57, but what has happened is that in recent years we have actually done MOSFETs and IGBTs and silicon carbide MOSFETs and GaN devices. All these devices, so all this power electronic technology has actually improved significantly. So what that does is that the charging of these vehicles have become much smaller now, okay, compared to what it was, let's say 50 years back, right? So that has also improved our understanding of how a EV will be helpful for us, right? So what we will do in this course is that we will look at these technologies. What are the power electronic technology that has changed, and what are the peripheral technology that goes with this power electronic technology, so that the charger can be made more efficient and more reliable. When I am saying reliable and efficient, I am actually not concerned about whether a charger is able to use energy efficiently. No, I am actually not concerned about it. What I am concerned about as an Indian is that the charger should not go wrong. Okay, that's the first thing. Okay, and the second thing is that if it goes wrong, our manpower should be able to fix it very, very fast. Okay, if these two things we can do, okay, we don't, it's like buying a two-wheeler, right? I mean, I used to have a vehicle called Honda Activa. Okay, the worst vehicle in terms of kilometers it will go. Okay, it will go some 20 kilometers or something. My car will go far higher than that. Right. But the good part about that vehicle is that whenever I need, it will go. Okay. It will not. It has never given me any wrong. I mean, it will not bet nahi jayega kahin pe. Right. So that is something that is very, very required for an Indian scenario, because we see India is not US. So India is a country that is very hot. You don't want to be getting stuck in the warm sun. There are a lot of pollution outside. Pollution means धूल वूल होता है. Like not in US, it's not like that, right? So that is why we want things to be reliable, so that it will bring me back home. All right. So that is what, when I'm talking about power electronic technology, I'm talking about the reliability part of it. So which, it is not about making it fancy or using silicon carbide or making it fancy. No, it is about making it efficient and making it more reliable and making it cost effective. Okay, so that it doesn't cost a lot to fix your things, right? So this is what will be required if we want to make the charger efficient and more reliable for our application. So this, we will learn the art of how to do that. Okay, and we will tell you what are the type of circuits that are used, what are the type of peripheral circuits, like how do you design the heat sink, how do you design the fan, whether a fan is required or not, how do you design the magnetics, how do you design the PCB, all these things we kind of talk about to make the charger there, so that you can pick any one of them, and that you can build a carrier on it, right? So this is how charger. There are two types of chargers you will see in an electric vehicle. One is the onboard charger, another will be a off-board charger. So onboard charger, because it is inside the car, it is normally like 3 to 6 kilowatt, and so it will take a AC and then convert it into a DC. This charger will convert it into a DC and give it to the battery. But regarding DC charger, because the charger is outside, you can have a bigger circuit there, and they will directly make a DC and give it directly to the battery. There are two types of chargers you will see. We'll study about both these chargers and what are the fundamentals required. So every electrical engineering concept that will be required to understand these things, we will cover. Okay, it's like you need to have some basic understanding of electrical engineering. Like, you cannot ask me that what is a resistor. That will be not fair, because I will expect that you have an engineering degree, you know what a resistor is, what a capacitor is, what an inductor is. So with that, I will start my thing, and whatever technology you need to understand, whatever I am talking about, I will cover the basics of that. I understand that many of these things you might have done a little bit little time back, and you might have forgot it, so we will cover it. And this phase also, like this first phase also, we like like that was one of the questions that was asked, that what I should know. I said, you don't know, and you need not know anything. In fact, you should not know anything, so that whatever you need to know, I can tell you, and from there I can establish the technology for you, right? So now the cost wise, if you look at it, I just give an example here, that a normal car 20 kilometer per liter, so 5 rupees per kilometer kind of a thing. But for a EV, let's say 23 miles it is going per 1 hour of 1 hour of charging, right? So what that means is that for 23, so you require 6.6 kilowatt to get to this thing, right? So 6.6 units, that means. So 6.6 units is like, I have taken 5 rupees per unit. I said a little bit low, I know. But yeah, so let's say it is 5 rupees per unit, and 33 rupees for 37 kilometers. So 23 miles is 37 kilometers. So it is about a rupee per kilometer. So you can see that EV is much more advantageous for us in terms of cost, right? And like I keep telling you that the charger is something that is outside. So and that is something that we want to build, and then EV is something that we are actually charging, right? So there are two types of communication that happens between them. One is the power, that means power from the charger will go to the EV, and then there is a communication. So the communication is something that will tell the EV whether the EV is capable of using your charger or not. So in order to understand this, you can understand this using this picture. Okay, if you are a movie freak like me, you might have seen this movie called Diwar. Okay, where this is one of my favorite actors. So Amitabh Bachchan will be a gold dealer basically. Okay, so what will happen is that like when Amitabh Bachchan will ask his boss that I want to pick the gold. The boss will give him a 100 rupees stone, 100 rupees note, and one piece he will give. Amitabh Bachchan will ask, what is the other piece? Now, other piece is with the gold guy. Okay, so Amitabh Bachchan will go there. The other guy will take that note and fix it, and if it matches, then the gold will be given. So you can think of this like the car, right? So this gold guy is your car, and you are the charger. So first thing that will happen is that when you go to the car, when the car comes to you and says that I will charge, the first thing that uh, car will ask is that are you capable of giving me a charging? So that will be called a protocol. So there will be information exchange, and whether the information matches each other or not will be the first thing that will be that the car will look for. Okay, so this is like the rupee, right? The 100 rupees note, right? So once the communication has been established, then the power can transfer. Okay, so this is the way this protocol will happen. So we'll talk about the protocol in the course. There will be like Professor Paningrai will he is actually a advisor to Niti Aayog, so he does this thing all the time. So I mean he will be taking at least 4 5 hours of lecture on how these protocols and these systems are developed for our EV charging EV charging infrastructure in India, right? So that he will be kind of talking about. So that will be the end of my lecture. I will just take up questions from you now. All right. Any questions that you have? I can just take it up. Because if you allow me to talk, I will talk for hours. I just don't want to do that.
Yeah. You can put your questions into Q&A and so we'll be happy to answer your questions. Nilesh, you can write your questions in the Q&A box and so we'll take it up.
Is it okay if they talk and ask me the question or no? You want them to write it?
Usually okay, so we have questions coming up. So usually they put it in the chat and we address it from there itself.
Okay, all right.
Yeah.
So the question is, what does you mean by range anxiety and charging anxiety? See, range anxiety is not something that people are concerned about. Charging anxiety is mostly people are concerned about. Okay, charging anxiety means uh, if you think about yourself, now you are with your family going to Jaipur, let's say from Delhi to Jaipur, and your anxiety will be that if I run out of petrol, what will happen? Actually, that anxiety will never be there in your mind because you will fill up your petrol and this and that, and you know that if I run out of petrol, there are petrol pumps around. There is no problem. The same thing is not true for charging. The reason that is not true for charging is that the charging takes longer time. Okay, compared to filling up petrol. So if the charging takes longer time, you are not sure how many chargers are available. There may be cars there already there, right? So and it takes a longer time, so people will just put their car and be sipping like Coke or coffee there, right? So this is what I mean by charging anxiety. Range anxiety, yeah, there, but mostly I don't know. I mean, at least in my mind, range anxiety is not a problem because uh, I I I know that all the cars it is not in my hand. So it is the about number of batteries they can put in, and mostly all these cars will have a range of 150 kilometer to 200 kilometer, depending on like if they are using a 30 kilowatt hour battery or not. If they are doing little bit more, then the range will be a little bit more. Don't go by what the companies are saying. So whatever the companies are saying, you just make it zero point 0.7 of that or something, so that I mean you are sure that that much at least it will give, right? Then hopefully I answered. You can type your answer if I have conveyed it properly. So I'll go to the next one. Ankur is asking, sir, will you give insight? No, yes, motors and control. Motors we will talk about. Controllers we will not be talking about. Controllers for the chargers we will be talking about. But drives we will not be concerned about. We'll be mostly concerned about the motors. Motor we will talk about what are the type of motors used for cars, trucks, and two-wheelers, or even three-wheelers, right? So those why they are used, all those things. I think Professor Saptarsi Basak, he is our expert. He normally discusses it pretty well. I have attended his lectures, and it is always very pleasant to hear him give a very good overview of why a motor is used and why that like what will happen. So motor is something that we'll talk about. Drives we will not be talking about it a lot. But if we are talking about the controller part of it, for a converter there will always be CCCV charging. That we will anyway talk about controller of EV chargers. Anuj has asked a question. Who is the nodal agency in VP2? Yeah, you think that I am the EV head of India or something? No, Anuj, am not concerned about the nodal agencies, and I don't know these answers. This question, I don't know the answer to the question. Okay, so there must be someone in the government who will be doing it, but I just don't know. Okay, normally these things happen with the help of only thing I know. Yes, only thing I will know. Like when I was at IIT Kanpur, we set up a charging station. We actually talked to DVENL, like the Dakshinanchal Vidyut Nigam. So they helped us because they were the one who gave us power. So we must have written letter to them. I have forgot what we did, but yeah, we must have. So they were the one. So I don't know who is the nodal agency, but definitely the power distribution company is included in that. Hello sir, is the course focus on technological part or no technological part purely? I am not a businessman at all. I don't know business. I mean, in fact, my mom used to say that if I start a business, I will go bankrupt very soon. Okay, I don't know business. I don't understand money. I don't understand money. So nothing. It was technology. Technology. I will only talk about technology. All right. So that is the answer to your question. What are the career opportunities in lithium-ion battery? Okay. See, Nilesh, let me be very honest with you, because see, you are asking this question uh, uh, to a professor who cannot lie. Okay, I cannot lie to you. Okay, I am not here to make you feel good. Okay, in fact, that is what I should be doing. Right. Let me tell you one thing. Okay, and you think about what I am saying. It will be a little bit harsh, but you think about what I am saying. Lithium ion battery is used in two places in a charging scenario. One is inside the car, another is outside the car. Why it is outside the car? Inside the car, you understand that you have a vehicle charger, you have battery. Outside the car, the reason it is actually used is because you can think about like many fast chargers, like which are 100 kilowatt rating, hundreds of them turning on at the same time, will put 1 megawatt or 1 gigawatt of energy demand on the grid. So we don't want the grid to be forced that way, right? So that is why what people do is they put battery, they put grid storage in a charging infrastructure. So grid storage is a part of charging infrastructure. The reason is that any sudden uh, requirement of energy actually comes from that storage, and then the rest of the energy will I mean the battery will basically charge when the the grid is little bit free, right? So it is like a shock absorber. Okay. So now the question is that, what are the career opportunities in? So there are two types of career opportunities, obviously, right? You can come up with your own technology for the battery, okay, which is very unlikely. Why? Don't feel bad about it. Even though any Indian company or anyone comes up with a battery technology, I will be highly questioning whether that will be accepted by the West. The reason is that they make their money this way. So they having vaccine, right? So they want to sell their stuff. Okay. So it is highly unlikely that those will be taken, but I may be wrong. There may be a technology that is absolutely brilliant. That is absolutely possible. Okay. But it is a very unlikely scenario. All right. But grid level storage is something that actually we will be actually using. We will need it. The reason is that it is outside the vehicle and we actually don't want the grid to have problem. And space is not an issue, at least in the outer part of the city, right? So therefore, what are the career opportunity in lithium ion battery? First one is thermal performance of lithium ion battery. Uh, Putting lithium ion battery and making it a case. That is what most of our companies are doing. They buy cells from China and then put them in boxes and then sell that it is Indian made. There's nothing is Indian made. They are all getting it from China, or some companies are making it, even though they are making it like lithium anyway has to be imported. Right. So lithium that is the problem with lithium, right? At least the lithium has to be imported. So what are the career opportunities? You can make batteries, you can make thermal with it, and you can use it and show that your battery is of value. Then another label that Professor Hussain normally talks about, he's a professor here, second life of battery. Like once the battery goes bad, what do you do with it? How do you extract all the components from it and use it? That also is a like second life of a battery is also a big career opportunity in this particular. So can we have charging infrastructure for business at a home using solar energy? Yeah, of course. I mean, there are many possibilities are there, but for that, the fundamental have to be kind of understood, right? So once you understand the fundamental, your brain as an entrepreneur will work much faster than what mine will work. Mine will work only to make you understand. Then your brain will take over once you understand the nitty-gritties of it. Okay, so hopefully I answered your question. Let me go to the next one. Hi, sir. Can you please give me some insight on the battery design and its requirement in manufacturing? Battery designing, we will we'll talk in the course. So normally, what happens is that there are cells that are there, which are 3.3 volt or something, 3.6 volt or something. Cells are there. So they are actually imported from China. So either China or Korea or some place, and then they are actually made into modules. Okay, so the modules will be, it can be like, let's say in a two-wheeler, it will be a 72 volt or 65 volt module. So that's why the voltage will be 65 or 72 volt. Now this module will be that, so then you can have many modules like that. But the important thing, Dhanraj, is that when you make these modules in using this lithium ion cell, you will require a BMS. BMS means it is making sure that all the batteries are charged and discharged properly. One thing. Second thing is that no battery is heating up. There is no thermal problem. So if the BMS is properly designed, there will be no fire, because BMS will take care that you are not forcing yourself. You are not stretching the limits of the battery. It will never allow you to stretch the limit of the battery. To answer your question, the battery will have battery cells, modules, connection of modules, but each of these modules can have its own BMS or have a completely like a single BMS, right? Sir, can we are from mechanical, so you will have no problem in like in this present course, Ankur, there are many mechanical engineers that are there. Once you have some understanding of electrical, whatever you require, I will actually tell you. Okay, and there are many mechanical concepts that you will always, like let's say I will talk about heat sink design. So there I will talk about thermal resistance and things like that, right? So this will be very, very easily understood by you. But now the question is that whatever is required, now all those basic electrical thing I will tell first and then go to the design, because we are not concentrating in this course about theory. We are not actually concerned about theory. Okay, our primary concentration is that how do you use this theory to make the module. And whenever you say that you have to make the module, it is engineering, it is not electrical or mechanical. Everything that you make, many of you mechanical engineers will be working for battery companies or power electronic companies, right? So there it's all engineering. It is not, because like you have to know the basics and then how the connection happens, because the connection happens in a certain way. How does the connection happen? And once you make the connection happen in a certain way, how do you operate it in a more efficient way? All right. So that we will be kind of covering. So Ghanshyam is asking, how can we fix the battery charger in rural areas of Maharashtra? Yeah, you can. You have to know how to what a battery charger consists of, Ghanshyam. Then only you can. Uh, why rural area? You can fix it in urban areas also, semi-urban. So it doesn't matter it's rural or urban, right? So one of the things that Ghanshyam people have been looking for in this kind of scenario is having they have vehicles which have charger, like their mobile chargers basically. Okay, so if a vehicle has gone down on the road somewhere, then actually you can go with the charger and charge the vehicle. So your truck will have lithium ion battery, extra lithium ion battery there with the chargers, and you can actually charge the vehicle. That is one way of. Second way of fixing it is that, I mean, these mobile chargers can be done, and mobile chargers can have alternate technology which will go there and fix the thing. So that these are the things that I can think of. Of course, for that you have to know what is inside the charger and how that kind of works, right? So is there any research doing with respect to reduction of weight of lithium? There are experts who will talk about lithium ion battery. I am an expert in charger design. So I cannot answer your question perfectly, but I know that there are alternate technologies that are being developed for lithium. See, I don't think many people are concerned about weight reduction of lithium ion and things like that. They're mostly in India. Their interest is that can we use alternate technology which are as efficient as lithium ion, so that all the raw materials will be available within India. Okay, so we don't have to depend on others. Okay, so dependence is one of the major hallmark of Indian thought process. Okay, that has been there for like hundreds of years. Like whatever I can think of, even during the like when IITs were made, like 50 years back, the primary thing that was driving this IIT establishment was that, I mean, we should have our own technology, and we should have our own manpower who will support our technology. Whether that has happened or not is a questionable thing, but that was actually the purpose of the thing, right? So I cannot answer the question, is there reduction in there, but alternate technologies are being explored. Motor weight again, though that Professor Saptarshi will be able to will be able to answer it better, and he does answer it this question. I don't know the answer, but yeah, he does answer this question. What sort of approvals are required to set up a charger? Yeah, Anuj looks like a businessman. Yeah, I that Professor, like people who work in setting of these chargers will know, right? Normally, like I told you, Anuj, that electricity companies are involved. Internet companies are involved, because you will be using the internet, because people have to find which charger is free, right? Using their phone. So telephone companies will be involved. So there are many companies that are involved, but whose approval is required, whether it is a one window approval or not, that I actually don't know. Okay, so but people will know this answer. I am pretty sure. Professor Paningrai will know the answer to this question. We know There are subsidies given by the government for buying EVs. Others are setting up charging infrastructure. I hope so. Yes. Yes, there must be subsidies that will be available for setting up, because unless see, government understands that in order to make EV popular, EV infrastructure has to be there. Unless people are sure that they can charge their vehicle anywhere, I don't think EV will take off. So that is why you will see mostly EV will be there in the cities, because like in the cities you have many places where you can charge, but you don't go for a longer ride with your EV. The reason is that you don't know whether there is a charger available elsewhere or not, right? So yes, I will hope so, but I again someone like Professor Panigrai can answer this question much better. Is it a DC motor? Normally, they do not use a DC motor here. They use a PMSM motor for EVs, permanent magnet synchronous motor. So that's why there will be an inverter there, and there will be a controller there. Okay, so DC motor is not used. This is a PMSM motor, or mostly PMSM is being used by many car manufacturers. So Mitra's question was that. So then Ganga Charan is asking, sir, what is the capacity? The capacity will be normally for a normal electric vehicle. If there is a open information, you can go to any car manufacturer, they will tell you. Mostly it is 30 kilowatt hour battery they will use. Right? So that gives about 200 kilometer, 150 200 kilometer kind of a range. What is the career prospect after the course? I don't know which companies are in the charging sector. So, see, the career prospect that I can see is that, so let's go. I won't know the answer to your question, Rana, but let me tell you what the course will offer you so that you can make an informed decision. So, we will be offering you, we will be telling you what is the technology of the charger. We will be talking about what is the technology of the motor. We'll be talking about what are the policies that are going with it. We'll be talking about the battery technology. Okay. So all these things will be covered. All the fundamentals will be covered. We'll be covering charger, you will know inside out, because I will be covering it. 70% of the course will be taken by me. All right. So 70, I will be covering all the charging. So you will know from ground up. I will normally what I do is that I will ask you certain questions at the beginning of the course so that you will know where you are. And at the end of the course, I will ask you the same questions again. All right. So that you will know throughout the course what you have learned, and you will see that you will be knowing charging and charging infrastructure design inside out. There is absolutely not a problem. Now, the question is that whether that will be of career prospect to you or not. That how can I answer the question? You tell me. I can only tell you that what I can give you. Whether you will be able to use it for your benefit or not is up to you. All right. So, how long and how many hours? So it's a 60-hour course. Normally it runs for five months. Okay, over the weekend it will happen. Every weekend I will be taking courses, and our like other faculties will be taking courses. Like I told you, 70% course will be taken by me. So over the weekend I will teach you. There will be 1.5 hour each. Okay, so per week there will be 3 hours of lecture. So that will be 60 hours. Then we have a like interaction in IIT Delhi. You can come to IIT Delhi, and whatever you learned actually you can see in the lab. So that is why we have this immersion program that we call, that will also be there, right? Yes, sir, I really love you, but okay. All right, thank you. Is there any other thing? What is the last batch? What was the batch? Have you recordings of any class? I see, these are not these are not taken care by me. They are taken care by Times group. So they take care of like all the recordings and things like that. But last batch was I mean, we had a mix of many senior level professionals. So it was good actually. When many of them were actually making mechanical and chemical engineering, but they also like the electrical aspect, because we'll do everything ground up. I will not assume anything that you know this. I will not assume anything. I'll whatever is required, I will take my time and tell you. Even though I say 60 hours, normally if it goes to 80 hours also, it doesn't matter, because you are coming to learn, so you will learn and go. Till you don't learn, I will not leave you. All right, so that is the whole idea of it. Recording, etc. I don't take care of those things. They are taken care by Times Group. What are the type of motors in two wheelers? That Professor. I, yeah, these are all. He probably told me all these answers. What are the motors used, and I forgot actually. But in four wheelers, I know that they use a PMSM. That much I know. For two wheelers, he told me what are the type of things Ola and TVS uses, but he will cover it. He will very nicely cover it, and he will tell you why they require this kind of motor in smaller vehicles, why a PMSM in bigger vehicles. Those also he will take care. And normally when he says these things, I normally hear other people asking him questions, right? And some of the interesting questions that will come are like whether torque has to be constant. Okay, because so we don't want the torque to have a lot of changes, right? So whether torque will be constant or not. What should you do so that the torque is constant? How does that affect the motor design? All these things he discusses actually, because I remember he took a class for Hyundai. Hyundai actually, like Hyundai Motors, we are their designated EV. We offer courses for them, right? So they will have specific topics, and they will tell us that you give. So in that he was these people were asking him all these questions. So it was very interesting to hear. But I forgot what he told. So I don't know the name of the motor, but four wheeler, I'm pretty sure it was a PMSM motor. Right. Thank you so much, sir. Looking forward to your presentation, future presentation. Okay, thank you. And then can you cover the sizing calculation software? Yeah. So normally, like for the charger design, we will use LT Spice in the course. LT Spice is a free software. In fact, you will be required to do the assignments and like design yourself. You will be like I will be showing you in the class one design, and I'll be giving you as an assignment another design, and you just do that. But for the charger design, I will take care of that using LT Spice. For the motor, etc., I don't think the design will happen. The motor, we will provide you motor, battery, all these things fundamental we will kind of cover. Okay, fundamental, like why they are used and what they are. We will not there's not enough time there to, because it's a like it will become too broad, right? So charger, everything that I say will be, you will be designing. It will be LT Spice you will be using, and actual design you will be selecting the MOSFETs, you will be selecting the heat sink, how big the heat sink should be, you will be designing the inductors, transformers, all these things from ground up you will design, right? And I will be using LT Spice for that, and Excel of course will be required. You will see how powerful Excel is, right? After I mean, already probably know it, but yeah, for many of you, for them it will be a surprise, right? So, but cooling system we'll talk about. We'll talk about the thermal design of the charger. But as far as the battery and the fundamentals will be covered. I don't think they don't have enough time to cover each and every aspect of it. It's a 60-hour course, so they will be having 30 hours to cover this motor, battery, policies, everything, right? So the idea is that through this course we will tell you what are all the things that are required in order to take up EV as a career. From that, obviously everything is not of interest to you. You will pick any one of them and try to learn more about it. So this course will give you a broad overview of what PV industries require. Okay, and very specific overview of how a charger is designed. Okay, and with that you will have you can launch your career in any of this topic and then take it forward. What are the requirements of a charging station? So requirement of a charging station is that आपको like whether you want a single phase charger, three phase charger. Normally we are having a charging station like if it's a three phase charging station, then it will be mostly a DC because the wattage will be high. If it's a single phase, normally the wattage will be up to 6 kilowatt or something, whatever the onboard charger requires. Right. So these are all the requirements of the charging station. Not only that, so there are layers of charging, layers of control. Like the first layer will be controlling the power flow, CCCB charging. The second layer will be controlling whether you have battery, solar, all these things are energy can be taken. See, the problem with electrical engineering is that once you generate energy, you have to consume it. There is nothing like you can save it somewhere. Battery you can say, but then the power flow has to be continuous, right? So this is the second layer will take care that where from the energy is coming and how you are charging, and the third layer will take care that I tap my RFID and it recognizes my vehicle. So this is something like cyber aspect, and then I pay money. That will be the top layer. So there are many layers of control of the charging station. There are many layers of hardware of the charging station. There are many layers of software for the charging station. So charging station requirements are many layers of things will be kind of there, and we will kind of cover it. Elon Musk is planning to set up a. Who is Elon Musk? Why are you thinking about Elon Musk? Elon Musk is not able to do anything in US. Why is he coming here and doing things and telling us 100 things? Okay, less. Okay. So, Elon Musk is planning to set up a industry in Maharashtra. What should I have? Nilesh, I think the more pertinent question will be that we want you to become this Elon Musk of India rather than following Elon Musk. That will be my suggestion to you. You decide now what to do. Why will Elon Musk tell you what to do? Who is he to tell? He cannot even take care of their own charging industry. Why will he come here and tell us what to do and what not to do? Okay. So the problem, Nilesh, I want you to become the Elon Musk of Maharashtra or India. Okay. And you tell us what should and should not we should not do. Right. Don't worry about Elon Musk. And inside, what are the state of research into sodium ion battery? Again, battery expert will take care, Shankar. We will have battery experts. We have a faculty from Apple who has joined us. So he will be taking care of the battery. So he will know your questions properly and answer it properly. I am not from that field. I cannot answer. Right. The long-term viability of EP depends on securing supplies of material. Okay. See, Nisha, see you have to understand one thing here. Okay. So see, in front of us this EV is growing up. That is why these questions are coming into our mind, right? So, but like I was asking one of our senior faculty members, little bit, I consider him my guru. Okay, so I was asking him that like what will happen to EV? Like what you are asking, I was to ask him the same thing. So he said that when he was younger, or when he was a researcher in the 70s, they said microwave oven was being invented at that time, 60s or 70s. Then he asked me, do you think that microwave oven has taken over cooking? I said, no, they have not taken over cooking. They have a place in our system, in our kitchen, but I don't think they have taken over cooking or something. Then he said that the same thing should happen with EV. I don't think EV will take over the world, but it need not take over the world. But if it satisfies certain aspect of our requirement, still it is okay, right? So you like people think that EV will take over. No, I don't think EV will take over. I don't. I mean, personally, I don't think EV will take. But yes, it will have its own value, because we can see that it has its own value. In terms of two-wheeler, think about all the three-wheelers that are there in Delhi. Okay, so it has its own value. So therefore, it will have a place. Our job is to see that, okay, there is a set of market that is getting aligned to this EV, how to take advantage of that market. Okay, so that we can earn a living, and not only earn a living, we can be self dependent. So this is a way of for Indians to think on their feet. I mean, currently no one is thinking on their feet. Westerners say that AI ML is good. We will say AI ML is good. I mean, why is Indian, why is no Indian saying that AI ML? I mean, they should come up with a plan themselves, right? Like people used to do it. I'll give you. Don't feel bad about it, Nisa. I'll just give you an example. See, when there was cloud burst in Kedarnath. Okay, you look at that picture. Okay, you look at the picture before the cloud burst and after the cloud burst. Before the cloud burst, there will be the temple and there will be a lot of area around it. I'm not a very religious person, but I am just talking about the engineering aspect of it. Uh, After the cloud burst, the temple stands. A 300-year temple stands. Everything that was built by the modern world was labeled. You just see the picture, you will know what I'm talking about. All right. What that means is that, like, Indians have this capability of thinking on their feet and having things that are absolutely amazing. So why this has gone away from our? I mean, you go to Taj Mahal, a person will take a like a torch, okay, and he rotates it inside that stone. I mean, the amazing colors will come out of that stone. I mean, you think that poverty, a person in poverty will build a thing like that? No, they were absolutely well paid. They were absolutely, because when you are not happy, you cannot bring your see, you cannot rush art. Like there is a like in Toy Story movie, na Toy Story 2, there is a word that you cannot rush art. So art is never rushed. Art is something that comes from within when a person is happy. So you can see that these are all art. All right. So this has kind of somehow gone from our system. We are always saying, "Arey, oh, EV, correct." We have to think on our feet and see what is good and what is bad for us, right? So this is something that you will, this kind of, I mean, I know that I'm probably making you upset by telling all these things, but I will tell you all these things throughout the course. That long term viability is there. Not we'll think about it. Now let's develop the technology first and see how it kind of works out. Let me go through your question now. Long term viability of EV depends on securing supply. Yes, we have to secure. Why secure? I mean, how can you secure many minerals? Do you think that Americans will allow you to secure minerals? I mean, do you think that we have enough military capability to fight with Westerners? No. So what we have to do is that what is inside our land, we can use that that will be our innovation, right? Whatever is inside my land, I tell you, I'm from Orissa. I went to this Orissa has a Sangrale, right? Let's take a so I went to that museum and I saw a stone and it was written silicon carbide stone. So for me, for Indians, it is a stone, silicon carbide. But the stone was taken by Americans and they built a MOSFET out of it. And we are buying that MOSFET for thousands of rupees. So why that innovation didn't come from us? Okay, the reason, whatever may be the reason, I'm not, I mean, obviously, we don't have the expertise to do it or whatever. But whatever is inside our land, we have to make sure that that helps us in the technology development so that we are not dependent on others. And India is not India doesn't assert power on others. It is not our style. We don't assert power. We are a very peace loving country. We will not assert power or anything like that. So whatever is inside our land, we will be content with that. So naturally, the technology has to come from within us. All right.
I think we'll take few more questions.
Yeah.
And then yeah.
Yeah, that's all right. Yeah, I keep on talking. I know. There is a course to give opportunity interact with face to face to face is not there, but online it will be there. It is as good as face to face. Don't worry. I mean, like initially the students were, I mean, our learners were skeptical, but after a few classes, they are like my family members now. So online they will just see me. They have a face in their mind, so that it will be as good as face to face. Yes. So it will be open the scope of EV jobs. For, yeah, job is dependent on you, Shivam. Okay, the job is not dependent on me. Right. Your success is dependent on you. Your success is not dependent on the world. The world will only give you, like our job that government has given us is to train our manpower. What you do with the training is your problem. Sir, in EV, it's a lot of questions. EV more efficiently used in public transportation like buses and metros rather than private mode of transportation. What will be the approach? We will be mostly talking about, listen, we'll be mostly talking about the technology rather than talking about cars or buses. So all the technologies are similar. Only there is a scale of technology, right? A EV for a two-wheeler and EV for a four-wheeler are same thing. The drivetrain will be same. So, but the power level and the technology will be a little bit different. So that we will kind of take care that that happens. And there will be a, like, you can come to IIT Delhi and there will be a we'll have immersion program where we'll be interacting with us there. But it's a, like, you have to take care of your. I mean that is something that is not mandatory. It is up to you whether you want to come or not. And sir, what is the resale value of EV? But how can I know what is the resale value of EV? I don't even own a EV. How can I know, Shankar? Huh? So you tell me what is the resale value of EV. But one of the things that will actually affect the resale value is that whether when you buy a car, actually you will be concerned about what is the resale value of it. Okay, now that I talk to people from Gurgaon a lot, I see that like in my time when my father will buy a car, the car is for life. But when I talk to my friends in Gurgaon, their thing is that, okay, for 3 years I need to have a car and it should have a good resale value. So the mentality of India has changed. So, but what the resale value means is that after 3 years, whether the battery is good enough so that it will be, because battery is the main component there. So obviously, if there is a like battery is of still of value, then the resale value will be more. But I don't know the answer to the question. Is the charging current of the controller as per? Yeah, charging current will be not as per the grid loading. The charging current will be as per what the EV will require. EV will tell us what the charging current is. But now, if the power cannot be supplied, then it can be scaled down. The charging current will be scaled down. Is something in the class. In Mahindra is saying in India, such a charging developed weight loading cannot. What is the so Professor Panigrahi will take care of this grid control, CCP, what are protocols, etc. He will take care. He is actually with Niti Aayog, so he has a good understanding of that. So he will take care of that. At the opportunity, the practical exposure to EV companies and the EV companies. I mean, we will be talking about. I mean, I will only talk about my experience with the EVs. We work with EV companies, but you will not be talking to an EV company. You will be just talking to me. Right. So what is the loan? I that you can ask Times. Mukund, you can ask Times. Okay. So hopefully I have answered all the questions.
I think the questions
Hmm.
which are directed towards time, you can get in touch with us and we'll be happy to answer the questions. And it was really an insightful session for, I think, the audience and everyone over here. And as we end, I would really like to thank our esteemed speaker, Dr. Shantanu Mishra, for sharing his invaluable insights and expertise with us today. Like your guidance has really illuminated the path for all of us, and we explore the exciting world of electric vehicles. And I would also like to thank each one of our audience. Your engagement and enthusiasm have made this webinar a truly enriching experience. And yes, we have many more sessions planned in the future, so stay tuned with TimesPro. And thank you all once again. And until next time, stay inspired and keep exploring. Thank you, sir.